Hello everyone, in this module we are going to learn how to create a histogram in Matplotlib, and the following are the topics that we are going to discuss. Firstly, we will learn what is histogram. After that we will see some characteristics of it. Then we will learn how to create histogram, and after that we will see syntax of a histogram to create it in a Matplotlib, and in last we will see examples related to this. So histograms are a graphical representation of a frequencies in the form of a bars. They show how much of the dataset belong to each category with non-overlapping intervals, and these categories are referred to as a bin in Matplotlib. Now we will discuss some characteristics of histogram that distinguish it from bar chart. A histogram is a graphical representation of a continuous data in a categorical form. And next one is, unlike a bar graph, there is no gap between the bars in the histogram. And the last characteristic of histogram is that the width of the bins is equal. And to construct a histogram graph from a continuous variable, there are few steps that we need to follow. And the following are the steps. For this, firstly we have to define the input values. After that, we will take the range of an input value, and then we will divide that range into a different intervals. After this, we will count how many values fall into each interval, and in last we represent it using the bars. In this way, histograms are created. So it is interval versus frequency graph. So let's take an example to get a clear idea of what is histogram. Suppose if I want to represent height of a different people using a graph, then I can use this histogram. So here I take a height of 40 to 50 people as an input value. Next I take the range of the height, and then I need to divide this height into a different interval. For example, so here I divide the range into intervals like 100 to 130, 130 to 160, 160 to 190, and so on. And then to represent how many people comes under which range, we use the histogram bins. So we can say that by using a histogram, we can display a large set of data. So now we will discuss some difference between bar graph and histogram on the following basis. So firstly, we will discuss about histogram. After that, I will compare it with the bar graph. On the basis of indicates, histogram shows distribution of a non-discrete variables, but bar graph shows comparison of discrete variables. On the basis of presence, histogram have quantitative data, whereas bar graph has categorical data. If we talk about spaces, in histogram the bars are touching, so there are no space between them. But in case of a bar graph, the bars don't touch each other, so there are gap between them. If we talk about elements, in histogram, elements are grouped together so that they are considered as a range. But in case of a bar graph, elements are taken as individual entities. So if we talk about width of a bars, there is no need to be same in case of histogram. But in case of a bar graph, the bars need to be same. So if we want to create a histogram in Matplotlib, we use the hist function, and the syntax is matplotlib.pyplot.hist, and in braces we pass number of the parameters which we need. So we discuss these parameters one by one with the help of examples. So the first parameter is x. X is nothing but the input values here, and we can take the values in array or a sequence of an array format. So we will discuss example related to this first. Here is the example. I explain to you. Firstly, I import the necessary library matplotlib pyplot as PLT. After that, I define the x by using the variable pen sold, and I take near about 30 values. Then I plot a histogram by calling the hist function and pass pen sold as a x parameter. Then I add a x label and the y label at the x-axis and the y-axis by calling the x label and the y label function. Here the x label represents the price range of a pen and the y label represents the number of pens sold. Then I call the title function to add a title to the plot so we get to know what the plot represents. So for this I add number of a pen sold of a specific price range. And in last I call the show function to display the plot. Now I execute this code and here is the output. So this is the graph. From here you can see that it divides the range by itself in the interval of 0 to 20, 20 to 40, 40 to 60, 60 to 80 and then from 80 to 100. And here you can't see the individual bars because the face color and the edge color of the bars are same. So in the next example we will learn how to differentiate each bar. So here X is the compulsory parameter and all the parameters are optional. If you have not passed any of them, it will take the default value. So the next parameter is bin. So bins is nothing but the interval. It takes the value in int sequence of an array or the string format. If you don't set any of the value, by default it will take 10. So now we will see example related to bins parameter. So here is the example related to parameter bins. In this example, I pass bins as a parameter to histogram function which is hist. So firstly I pass bins as an integer and set its value to 8. So takes the interval to 8. So here is the graph. You can see that when we does not use bin parameter, by default it takes 10 as a bin and the graphs look like that. And when we take bin as a 8, it shows the graph something like that. So with this we see how we can use the bin parameter as integer value. Now we will see how we can pass bins as a sequence. So here I create an array and pass 6 different values to it which create a sequence of array, and here I also pass a edge color to differentiate each edge. So here I set the edge color to K. Now I execute this code. So here you can see that now it looks something like that. In this example, it takes the range itself from 0 to 20, 20 to 40, but now it takes the range as a 10 to 20, 20 to 30, 30 to 40, 40 to 50 and 50 to 60. Now we will see the next way in which we take bins as a string. For this we pass auto to it which automatically sets the range. So here I execute the example. You can see that it automatically sets range for it from 0 to 20, 20 to 40, 40 to 60 and so on. The rest of the code is same. So the next parameter is a range and the default value for this is none. It can take tuple or none as a value. It is nothing but the lower and the upper range of the bins. If you don't specify the range, it will automatically takes minimum value of a x and the maximum value of the x as a range. So let's see an example related to this. So here is the code in which we discuss the range parameter. For this, I pass range as a parameter to hist function and sets its minimum value to 0 and the maximum value to 150. Now I execute this code and now you can see that its minimum value at the x-axis is 0 and the maximum value at the x-axis is 150. But in the default cases, it takes 0 as a minimum value and the maximum value as a 100. Now I will show you how it calculates the width of each interval when we change the range. So here is the formula. For this you have to take first maximum value of the x which is 150 in our case. Next you have to divide the minimum value of the x which is 0 in our case. After this you have to divide it with the bins value which is 8. This will give you the width of the bar. So the next parameter is density. It will take the boolean values which means false or true. By default the value for the density is false, but if it is true it will return the probability density. So here each bin will display raw count value divided by total count multiplied by the bin width value. So let's see an example related to this. Here is the code. So in this I will pass a density parameter to the hist function and set it to the true. Now I execute this code. So density is nothing but you can see that In the cases in which we does not use density parameter, the highest value of the bin is near about 8. But when we take density as a true, it will calculate it by using the formula. I will show you. So it's take raw count as a 7.5, as here the highest value is near about 7.5 to 8, so I took it 7.5. Next, the total count means the values which we take as a x. So here I have 30 values, so I write as a 30. Then it count the bin width. The bin width is nothing but the maximum value of x minus the minimum value of the x divided by the number of the bins. So it is 100 minus 1 divided by 8. So it gives the result near about 0.020. So you see that here's the highest bar is near about 0.200. So the next parameter is weight. It takes the value as an array of a weights or none. By default it has none value and it should be same of the x shape. So I will show you example. So here is the example. Here I change the pen sold values, which means x values. So I define maximum of 7 values. And next I call the weight parameter in the hist function and set different weights to it. I set 3, 2, 6, 2, 4, 5, 3. And I use bin as a sequence of an array also. Now I execute this code and here is the output. I will tell you what this weights means. From here you can see that in the range of a 5 to 10 we have only two values in our x array and it is at the position number 2nd and 4th. But here at the 2nd position we have 2 and in the 4th position we have 2 value. 2 plus 2 results 4. So here it shows the bar at the 4. In the next case, we use to represent in the range of a 10 to 20. In the case of 10 to 20, we have only one value, which is 16. It does not include the 20 in a range. So 16 is at the 3rd position and 3rd position we have weight is 6. So it represent the bar at the 6 and similarly calculate for all the bars. And now we will discuss the next parameter, which is cumulative. It will take value in the boolean either true or false, and by default it has a false value. So if it is true, histogram computed where each bin gives the count as bin plus all the bins value. The last bin gives the total number of the data points. So here is the example. I pass parameter cumulative to the hist function and set it to the true. Now I execute this code and here is the output. The plot shows the total count in the last bar. So the next parameter is the bottom. It takes value in array or a scalar like form. By default it has none value, by which we mean the atom value as 0. And it is the location of the bottom of each bin. And you maybe notice that we use this bottom parameter in bar function also. And you can set a same bottom for each bin by using a constant value. For example, if you want to set bottom as 5, you can pass 5 to a bottom and the bottom change to 5 value in every bin. And even you can set different bottom for different bins. So now we see example related to this. So here is the code for the bottom parameter. In the first case, I call bottom parameter in the hist function and set its value to 5. Now I execute this code and here is the output. And you can see that now the bottom set to 5. But in the default cases, the bottom set to 0. Now we will see an example related to different bottom for each bin. So now in this case I pass bottom parameter and set its value in an array or a list. So I execute this code and here is the output. You can see that the bottom for each bin is differ. For the first bin the bottom is 2, for the next bin it is 3 and for another one it is 4 and for the last one it is 7. So by using bottom in an array or a list form, we can set different bottom for different bins. So the next parameter is the his type and the default value for it is bar. So this parameter is used to change the type of the histogram which we want to draw. We can have different value for it. First one is a bar, which is a default case. The next is a bar stack. Another is step, and the one more we have, which is step filled. So let's see an example related to this. So here is the example for parameter his type. Before explaining you the code, I tell you one thing. The previous examples you see, each example plotted histogram in a bar type by default. Now we will see an example in which we draw a histogram in step type. So for this I pass a histype parameter and set its value to step. Now I execute this code and you can see that it creates only boundary of the bins without any filling. So now we will see the another case in which we draw histogram in step fill type. So for this I pass histype parameter to hist function and set its value to step filled. And now I execute this code and you can see that it fill up the blank space of the step with the default color. So there is a one more type which is a bar stacked. So we will discuss this type later on. Now we will discuss the next parameter, that is align. This parameter is used for the alignment of the bins. So we have three values, left, mid and right. By default it takes value as a mid. So let's see an example. So here is the example. In this code I pass align to the hist function and set its value to left. Now I execute this code and here is the output. So you can see that it transfers the values to the left sides of the bins. So here you can see that 35 is shown at the left side of this bin, 20 is shown at the left side of this bin, similarly like that. Now we will see what will happen if we change alignment to the right. Now I execute this code and for changing it I simply pass a line parameter and set its value to right. Now you can see that the tick and the label which is shown left side of the bar now transfer to the right side of the bar. So I hope with this you clearly get a hint what a left and a right alignment does. Now we will discuss the next parameter, that is orientation. It has two values, vertical and horizontal. By default it has vertical value. So if we use horizontal, it transfers the bins to the horizontal orientation like the bar edge function does. So let's see an example related to this. So here is the code. To change the orientation to the horizontal, I pass the parameter orientation to the hist function and set its value to horizontal. Now I execute this code and you can see that the bins are rotated in a horizontal alignment or orientation. In the bar cases, we change the function. Instead of a bar, we start using bar h, changing the alignment of the vertical bars to the horizontal bar. But in the histogram case, we have a special parameter orientation to change the orientation of a bins. So here I tell you, in the vertical cases, I use X label as a price range for a pen and the Y label for the number of pens sold. But when I change the orientation to horizontal, I also change Y label to the price range of a pen and the X label to the number of a pen sold. So you have to make some small changes in the code if you call X label and the Y label function. Otherwise, it will move its intervals itself. So the next parameter is R width. You can take float value or a none. By default, it has none value. And This is the relative width of the bar as the fraction of the bin width. So let's see an example related to this parameter also. So here is the code for changing the R width of the bins. So here I pass the parameter R width to the hist function and set its value to 0.8. Now I execute this code. You can see that the width of the bins changed to 0.8. And now I change it to 0.3. And now I execute this code. And you can see that the width of the bin is changed to 0.3. Now we talk about the next parameter, that is log, and it takes value in boolean, either true or false. By default it is false, but if you set it to true, it will convert histogram axis to the log scale. So let's see an example. So here I pass a log parameter to the hist function and set its value to true. Now I execute this code and you can see that the values are converted to the log. By default it has value like that 0.2, 0.5, but now it convert this value to log. Now we will see the next parameter, color. It takes value of a color or an array like colors, which we mean array of colors. It is used to change the color of the bins. I will show you example. So here is the code in which I pass a color parameter and set it to pale green. Now I execute this code and you can see that the color of the bar changed to pale green. You can even pass array of the color to change color of each bar like we do in bar chart cases. And the next parameter is stacked. And the stack parameter take values as boolean, either true or false. By default it is false and it is used to stack the data on the top of each other. It works similarly like stacked bar chart. So let's see an example, and here is the code for creating the stacked histogram. So before explaining you the code, I will tell you one thing. When dealing with a stacked histogram, we have either two or more categories plotted on the same graph so that we can plot these categories on above of the each other. So in histogram function, we can do it in two ways, either by using a stacked parameter or by using the hist type parameter. So firstly I explain you how we can create the histogram using a stacked parameter. So for this I firstly import the necessary libraries, which are Matplotlib pyplot as plt and numpy as np. After that I define the data coordinates, and for defining the data coordinates I use random.random function of a numpy and pass 200 value to it. Next I use sine function and the cos function of a numpy and assign x value to both of them. So with the help of these three coordinates, we will create stacked histogram with three distinct categories. Next I call the hist function to create a histogram, and to make it in a stacked histogram I pass three values as a x in the form of array x, y and the z. Next I call the bins parameter and set string value to it auto, and after that I pass the stacked parameter and set its value to true. Then I call the x label and the y label function and pass value to as x-axis and y-axis. And I also give title to the plot by calling the title function stacked histogram. And in last I call the show function to display the plot. Now I execute this code. You can clearly see that each of the categories are placed one above the other. In the cases of bar chart, to convert it into a stacked bar chart, we have to do lots of coding. But in the case of histogram, we use one parameter named stacked and pass two value to it, and simple histogram is converted into a stacked histogram. So how easy it is in a histogram case. So you can see that when we does not use stacked case, it will create bins like that. But when we pass stacked parameter and set its value to true, it will create stacked histogram. Now I told you, I will tell you what the hist type bar stack does later. So now I explain you this. So in this case, I use hist type parameter and a set value to it bar stack. It will also convert histogram to a stacked histogram. Now I execute this code and you can see that it will also create a stacked histogram. So you can use any of the method as per your choice. So the next parameter is label. It will take value as a string or none. It add labels to the plot. Now we will see how to use it. So here is the code to add labels to the plot. So here I call the label parameter in the hist function and pass a list of labels. We have three data coordinates to plot it. That's why I pass three labels to be added. The first label is the label 1, label 2 and the label 3. So to show that label on the plot, I call the legend function. So it will show the labels on the plot. Now I execute this code and here is the output. So you can get to know with the help of labels which color of the bins represent which category. So with this, blue color represent label 1, orange color represent label 2 and the green color represent the label 3. So with this we get complete detail of a histogram in Matplotlib. So in the next video we will study how to plot a scatter graph.